This is 8/6. More power series. More power to the series. Okay. Now, you probably don't remember this one, James.
Yes.
Do you remember this one? What's special about this infinite series? David. We can move over further. Okay. Guys, let's get this done. Okay, this is a polynomial, but what kind of series is it? Okay, it's called a power series because all of these powers are whole numbers. Powers are whole numbers. They're polynomials. Okay? And what does this look like in summation form? I don't really care where it starts. Well, I do. It's 0 to infinity. Okay? And it's x to the n. James?
Yes.
What is that series? It's special. I can find its sum. Hint.
Geometric.
It's geometric. And unless you want me to get the graphing calculator out again, we put this on our calculator, and we took this, and this is one you have to memorize. What is our A value? 1. What's the R value? X. When does this converge? When the absolute value of X is less than 1. Remember that? Geometric series converge when the common ratio is small, between 1 and -1. So, okay, so what am I going to do? S equals A over 1 minus R. Well, that's 1 over 1 minus X. So what I'm telling you is that this function is 1 over 1 minus X. Sorry, I'm supposed to say 1 minus X. You guys have a question? Yeah, put the food away, please. Okay. That's called, this is the power series for that rational function. Why do I care about power series besides the fact that they're on the exam? Because this is not an easy function to work with. It's not easy to differentiate. It's really easy to differentiate this one, isn't it? I just have to do the power rule. I can do f prime of x on this side, can't I? David, over there. Now, I don't know. Guys, we got to get this. This is the most important part of what we're doing. Okay, I put this on the calculator. If you want me to go and put it on the calculator again, I will do that. But these two things are equal, provided that the absolute value of x is less than 1. It's only equal then. Questions on that? Do you want me to graph it again? I'm sorry, what? Do you remember me graphing it? You probably weren't here. Oh, then we better do it again. Oh, I was going to put it on the Inspire because the picture's better. But let's try it with the Inspire. I have that up. Okay, so I want a new one. File. New. Okay, we're going to do a graph. And I want to see my handheld over here, but I don't want to see all of that. Okay. What did I just do? Sorry. There we go. My mistake. But I don't want to see the screen keypad. There we go. So in y1, I'm going to put in 1 divided by 1 minus x. And these are always standard windows that this always goes with on this calculator. What I like about this is because it's now in color, right? And now, I'm not sure I know how to put the summation on this, so let's just put in some terms. Because it's not that hard. And so I want 1 plus x plus x squared plus x cubed plus x to the 4th. How many do you want? 10. Let's do one more. Plus x to the 5th. Good. There it is. It's the green one. So you see, they're really close as long as you're between 1 and negative 1. I don't want text. I know, I'm trying to drag. I don't want that. I can do it with my computer better. I have more control. I don't want a text. I know, but I wanted to drag my axes. There we go. I wanted to shift them. So I got to grab the origin to shift. Well, anyway, you can still see it. But it's kind of nice to see that it's really close. You know, wherever 1 is, but it's right here. 1 and negative 1 and 1, right. If you put all the terms in, it's the same. Yeah. It is crazy if you think about it. Okay, well, we're going to find some more things like that. I'm going to put the picture in here, though. This is just, I would hope they would change that because it's a pain to do that. Okay. Well, let's go on. Now, I have this function. I would like to get the power series for it because I can differentiate and integrate the power series, plus the calculator is actually how it works. I've been told that the calculator uses the power series to find e to the x and the sine of x because it's an easy calculation to do 1 plus x squared. It's much easier than trying to do that. Now, I know that this one is equal to, that's the first one, okay. 1 plus x squared plus x cubed. Now, these guys are, this is a family. The geometric series is a family, Kevin. Okay? I want to write this is the tricky part right here, as a power series. Well, you know what that looks like? It looks like this, 1 over 1 minus negative x squared. Do you agree that those are still the same things? This one up here with this one right there. Because I want to write it as a power series, and it's related to this one. They're cousins. It's a family, and you're going to find all sorts of power series. Once you know the first one, you can find all sorts of other ones. So I'm going to put in minus x squared in place of my x. Because now if you don't look at that, it's some function of x. I'm going to put that right in here for x here, and there, and all the way through it. And that's what the quiz is going to be like next week. So let's do that. So it's equal to 1 plus x, but it's not x any longer. It's what? It's minus x squared. Be careful. It has to be 1 minus something. Plus, and then it's minus x squared squared. Minus x squared cubed. And then they'll ask you for the nth term. So it's minus x squared to the n. Do you need to simplify it? We can. What's this? Because, you know, we're going to use this later on anyway. You'll see this in the homework, probably. So this is 1 minus x squared plus x to the 4th minus x to the 6th. And it's minus x to the, whoops, we got to be careful. That's not true. It's minus 1 to the n, because what are the signs going to do? They're going to do what? Alternate. And if I had included the negative in with the x, they would not have alternated. Because if I take negative 1 to 2n, 2n is always an even power, so it's always positive. Because what I substituted in here is negative x squared. And when I put it in for x, I still keep the negative. It's not this. We kind of wish it were, but it's not. So that's an alternating series. When does this converge? Hey guys, this will converge just like the original one. The absolute value of x is less than 1. Even though I use the first one, it's still going to converge. Or actually, I should say this is my x. I'm thinking of the derivative rule. Amplify of negative x squared is less than 1. So it converges for x squared less than 1. So x is going to be what? Between 1 and negative 1. You do have to put that in. Never hurts to check. And you could check the endpoints. If you check 1 and negative 1, they don't work. But that's because it's geometric. Is that okay? I don't know what my slide looks like, but what if I had 1 over 1 minus x? What if I had an x here instead? Couldn't I write this as x times 1 over 1 minus x? And I know what 1 over 1 minus x is. It's x times x to the, let's not do it in summation form. Let's do it written out. And that's up to you. By the way, you're going to need, and I've got to get the solutions up there. No, they are up there. I don't know. Mrs. Horseman did the solutions. I would stop at a certain point and show you how we get to the book answer. You're going to have to check with the solutions because we don't care if you simplify. And the book answers are going to be simplified. So. Because I didn't substitute x in for 1. Negative x squared. I put it right in the first one right here. And this is x cubed, etc., x to the n. So now, when I multiply that out, what do I get? X plus x squared plus x cubed plus x to the 4th, and it's x to the n plus 1. You don't have to put it in sigma. But the answers in the book are going to be in sigma. That's why you're going to want to use the solutions. Okay, so what I did was I took this one and multiplied by x. There are all sorts of tricks. These are all tricks how you can get other power series. And they're all related. This is x times the geometric series. Well, shall we try another one? Remember, all I know is this. That's all I know. I'm going to write it in summation form because I don't have any room. I've got to get this to look like that. This one's trickier. First off, I want the constant to be first. So this is 1 over 2 plus x, right? I didn't do anything fancy. And I want the first constant to be 1. How am I going to do that? Factor out by, can't divide because it's not an equation. Factor out 2. So it's an algebraic trick. So this is 1 over 2 times 1 plus what? Not x anymore. X over 2. Is that okay? I got to get it to look like 1 over 1 minus x, math. And this is the section that's really important because there's lots of multiple choice questions on this topic. So don't skip 8-6 because there's lots of questions there. So that's actually 1/2 times 1 over 1 plus x over 2. Can I write that with a negative? That way 1 minus what? Negative x over 2. Right? So now, that's my input in my power series. And the 1 over x minus 1, I'm going to write it here so we have it in front of us. You have to memorize this. So the hard part is going to be recognizing the trick. And the trick is to get it to, get it to look like this, 1 minus x. I wish it were x minus 1, it'd be easier, but it's not. And so this is going to be 1/2 times all of that. So what am I going to put in for 1? 1. What's x going to be on this one? You substitute this in for x. It's what? Minus x over 2. And then you're going to do plus. And now you're going to put it in here. And so it's minus x over 2 what? Squared, right? Is that okay? Plus. And then I'm going to put it in here in the cubing one. Minus x over 2 cubed. And you don't have to simplify. So don't worry about it. When I put it into the nth one, it's going to be x to the n, so it's minus x over 2 to the n. You don't have to simplify it. Yeah, just think about that. And if you want to multiply it out, you get 1/2 minus x over 4. You know, you can do that if you want, but you don't have to,
Now, why would you need that?
because it goes forever. Then there's the next x to the n plus 1. In summation, because in summation, it would be 1/2 summation, and it's going to start at 0, so I get the 1, and it's going to go to infinity. And it's going to be minus x over 2 to the n. Now, how do we get our interval of convergence? This here, absolute value of minus x over 2 must be less than 1. Now, to get the radius of convergence, you can't have a coefficient in front of x. So it's just this, absolute value of x over 2 is less than 1. So the absolute value of x is less than 2. Multiply both sides by 2. So what's the radius of convergence? It's 2. This is r. And it's centered at 0. So what's the interval? You hear the difference? The interval is going to be interval notation, and the radius is just going to be a number. How far you are from where you center it. No, because it's geometric. Wouldn't ever hurt to test it, though, if you want to be sure. Because you have a lot of stuff that's going to be in your head at that time. Right? Because it never converges at the endpoints. If you put 2 in here, this is going to be negative 1 to the n. If you put in x equal to 2, then that's negative 1 to the n. That doesn't converge. If you put in x equals negative 2, then I'm going to get 1 to the n, and that doesn't converge either. It's because of the fact that this is 1 plus 1 plus 1. Even though that's alternating sign, I don't know if it stops at 0 or if it stops at 2. Nothing inclusive. So these new geometric ones, these endpoints will not converge. This is all from a geometric one. We'll do Taylor's, and guess what? We'll have to check the endpoints from the Taylor's, which is what I gave you. I gave you the Taylor polynomials because it's part of the problem. We don't know how to do that yet, but you have the information there so you can do the ratio test on it and your interval of convergence. Oh, what about this one? Oh, and I'm going to cheat a little bit.
What?
You can't cheat. But isn't this the same as this? It's x cubed times 1 over x plus 2. That's why I said I'm going to cheat. I got to go back to the one before it. I want to see if I can copy it. Where is it? It's right here. Okay. It's this one. Oh, yeah. And that's where you're going to, I want to group these. And that's the way you're going to do your homework. Copy.
Can you do that on the AP test? Sheet like that?
That's when you get iPads, right? Okay, so this is going to be, that's what this one is. I'm going to move it here to the side. And this is going to be times x cubed. Whoops, all the way over there, sorry. That's all there is. So it's x cubed times the summation of negative x over 2 to the n, and you could leave it that way, or you can bring the x cubed in. You can do it this way too. And I don't know if you want to do any simplifying, but it's x cubed times this. If you're going to do the ratio test on this, though, you would have to simplify that. You have no choice. I'm sorry. No. Because we're actually accomplishing something today. Okay. Oh, is that it? Oh, there it is. What do you want? Oh, no. Oh, I forgot the 1/2. Let's put it out front. There you go. I have it there. Now, I forgot to copy the 1/2 down. That's a copy error. As long as I had it right here, and it's clear it's a copy error, most of the time it's clear. Sometimes it's not clear, but we don't penalize you for that. I make a copy error, right? Because you're going, oh, I can see they have this all right, and they just forgot the 2 or something. Yeah, right, absolutely. So that's 8-6, day 1. I want you to practice with that before I do day 2. We'll do day 2 on, we can do it Monday and tomorrow can be a work day. But when we have a work day, you need to work.
We always work. Well, I always work. I can't speak for the other person.
And this is going to be on the exam. They'll have problems like this. And you're going to go, oh, I know what that is. I have to know the 1 over 1 minus x. So I'd have to change this like we did before and then multiply by x cubed. You can certainly look at those. Which one? Well, I'll let you guys work on them first. Because you know what? You can look up the answers. It's just the ratio test. No. Here's what you can do. I'm going to put this right here. On 2009, you can do part C. It was too hard for me to cut. On 2006, you can do A. And the last one on 2005, that was a tough one, was C. Okay, you guys? That's all you can do off this pink sheet. Yes, so can't do the whole thing. And then I gave you the Taylor polynomials. Later on, when we do that, we'll do that. Okay, guys. Questions? I'll work it out too, because I want to see if I can do it. No, I can do it. Were there any questions out of the homework you want me to go over? I don't think you've worked on it yet.